Good morning students. Now I am going to discuss about the basic concepts and zeroth law of thermodynamics. What is thermodynamics? Thermodynamics in physics is a branch that deals with heat, work and temperature and their relation to energy, radiation and physical properties of matter. To study thermodynamics, we should know the basic concepts such as system. System is a specific portion in the universe with a definite boundary on which thermodynamic study is done. Okay, so a thermodynamic system is a specific portion in the universe with a definite boundary on which thermodynamic study is done. Next, surrounding. Everything outside the system that has a direct influence on the behavior of the system is known as surrounding. Okay, everything outside the system that has direct influence on the behavior of the system is known as surrounding. Next, thermodynamic system. A system whose state can be represented and explained in terms of thermodynamic coordinates such as pressure, volume and temperature and entropy is known as thermodynamic system. A quantity of gas enclosed in a cylinder with a frictionless piston is known as a thermodynamic system. So this is an example for thermodynamic system. That is a quantity of gas enclosed in a cylinder with a frictionless piston. So what is a thermodynamic system? A system whose states are represented by pressure, volume, temperature and entropy. This thermodynamic systems are of 7 types. They are macroscopic system, microscopic system, open system, closed system, isolated system, homogeneous system and heterogeneous system. Now we shall see one by one. What is a macroscopic system? The system in which the number of particles is very large is defined as macroscopic system. For example, 1 mole gas contained in a cylinder. Next, microscopic system. The system in which the number of particles is very much less is defined as microscopic system. For example, a single atom or 1 mole. Next, open system. So the system which exchanges both matter and energy with the surroundings is called an open system. For example, an open vessel containing a boiling liquid. So when a liquid is boiled, it is going to exchange both matter and energy with the surrounding. That is an open system. Next, closed system. So the system which only exchange energy with the surroundings but not matter is called closed system. Example, a closed metal container holding any substance. Next, isolated system. A system which neither exchanges energy nor matter with the surroundings is called an isolated system. Okay, so what is an isolated system? A system which neither exchanges energy nor matter with the surroundings is called an isolated system. For example, a thermos flask holding a hot or cold solution is an isolated system. Next, homogeneous system. A system which consists of a single phase or uniformity throughout is called homogeneous system. For example, a system with only gaseous mixture or only liquid or solid. Okay, this is a homogeneous system. That is a system consisting of single phase throughout the system. Next, heterogeneous system. When a system consists of two or more phases which are separated from one another by a definite boundary is said to be heterogeneous system. Okay, so when a system consists of two or more phases which are separated from one another by a definite boundary is said to be heterogeneous system. For example, melting ice, two immiscible liquids. So if you consider two immiscible liquids, those two will be separated by a boundary. They will not mix each other. Okay, so wet steam, alloys, rocks, etc. are examples of heterogeneous system. Now, macroscopic and microscopic description of a system. The behavior of a matter can be studied at two levels. They are macroscopic and microscopic. So this is the difference between macroscopic description and microscopic description. So macroscopic approach is also referred to as classical thermodynamics. Microscopic approach is also referred to as statistical thermodynamics. In macroscopic description, the system is made up of certain quantity of matter without taking into account the events occurring at molecular level. Okay, so here in macroscopic description, what is the meaning of macro? It is big. So here we are going to consider certain quantity of matter, okay, without taking the system at its molecular level. But in microscopic description, the system is made up of very large number of discrete particles referred to as molecules. That is, in microscopic description, we consider the system in its molecular level. Next, in macroscopic description, when describing a system using macroscopic approach, only a few properties such as pressure, volume, temperature are required. This makes this approach simple, whereas while describing the microscopic approach, large number of variables are needed, and this makes this approach complex. Next, macroscopic properties can be sensed by the human because it is big. So a human can easily sense the macroscopic properties, but the microscopic properties cannot be sensed by the human. Then the macroscopic properties, in this the variables can be easily measured, whereas in microscopic properties the variables cannot be measured, but it should be calculated. So these are the difference between microscopic and macroscopic description. Next comes thermal equilibrium. So what is a thermal equilibrium? A thermodynamic system is said to be in thermal equilibrium if any two of its independent thermodynamic coordinates x and y remain constant as long as the external conditions like temperature remain the same. That is, if any two of the independent thermodynamic coordinates x and y, okay, for example pressure and volume, they remain constant as long as the external conditions like temperature remain the same. Now consider two systems separated by a diathermic wall. What do you mean by diathermic? Diathermic wall is the one which allows heat to transfer between two systems, whereas adiabatic wall is the one which does not allow heat to communicate between two systems. So consider two systems separated by a diathermic wall. The pairs of coordinates corresponding to each system will change spontaneously until an equilibrium state of the combined system is attained. That is, consider two systems which is separated by a diathermic wall. So diathermic wall is the one which allows heat to transfer between two systems. So if the pair of coordinates corresponding to each system is going to change, then they will change automatically, okay, until an equilibrium state of the combined system is attained. Okay, so the two systems are then said to be in thermal equilibrium with each other. So consider two systems with two sets of coordinates like pressure P1 V1, P2 V2. So in one system, if the pressure and volume is going to change, okay, so the second system will automatically change itself so that an equilibrium is maintained between the two systems. Okay, so it will change, the second system will change spontaneously or automatically until an equilibrium state is obtained between these two systems. Okay, so such a system are said to be in thermal equilibrium with each other. And for diathermic wall, example thin metallic sheets. Adiabatic wall, they are thick layers of wood, concrete, etc. Next, Zeroth law of thermodynamics. Imagine two systems A and B separated from each other by an adiabatic wall. So we know that adiabatic wall is not going to transfer heat. So two systems A and B separated by an adiabatic wall, but these two systems, they are in contact with the third system C through a diathermic wall. Diathermic wall, it transfers heat between the system, and the whole system is surrounded by an adiabatic wall as shown in the diagram. So experiment shows that the systems A and B will come to thermal equilibrium with the system C. Okay, so experiment shows that the system A and B will come to thermal equilibrium with the system C. No further change will occur if the diathermic wall is replaced by the adiabatic wall. Okay, so this is the diathermic wall and this is the adiabatic wall. If we replace these two walls, okay, then even after replacing, no further change will occur and the systems A and B remain to be in thermal equilibrium, although they don't communicate directly. Okay, so definition. With this concept, the definition of Zeroth law was framed, that is, if two thermodynamic systems are in thermal equilibrium with the third system, then they are in thermal equilibrium with each other. Okay, if two thermodynamic systems are in thermal equilibrium with the third system, then they are in thermal equilibrium with each other. This was given by Ralph Fowler in the year 1931, long after the first law and the second law of thermodynamics was framed. Okay, hence it was named as Zeroth law. This is about the basic concepts and Zeroth law of thermodynamics. Next comes the concept of temperature. So Zeroth law is the basis for the concept of temperature and for the use of thermometers. The temperature of a system is a property that determines whether a system is in thermal equilibrium with other systems or not. Okay, so temperature of a system is a property that determines whether a system is in thermal equilibrium with other systems or not. Temperature is a scalar quantity, hence the temperature of all systems in thermal equilibrium is represented by a number. So we say like 100 degrees Celsius, 200 degrees Celsius, like that. So we express temperature in a scalar quantity. Next comes thermodynamic process. The state of a given thermodynamic system can be expressed by various parameters such as pressure, volume, temperature and internal energy U. Internal energy is nothing but the total energy of the system when no force is exerted on the system. Okay, so if any two parameters are fixed, say P and V, that is pressure and volume, then T will be automatically fixed according to the equation PV is equal to RT. Okay, so if we are going to fix two parameters P and V, then T will be automatically fixed according to the equation. This is the perfect gas equation, that is PV is equal to RT. So no change can be made to T without changing pressure and volume. Okay, so as long as we don't change the pressure and volume, the temperature will not be changed. Such phenomenon in which the state of system is changed by changing two independent parameters from P, V and T is defined as a thermodynamic process. Okay, so what is a thermodynamic process? That is, if we fix two parameters, automatically the third also will be fixed according to the equation PV is equal to RT. Such process in which the state of a system is changed by changing two independent parameters PV and T is defined as thermodynamic process. There are four types of thermodynamic process. They are: first one, isothermal process, a thermodynamic process that takes place at constant temperature. What do you mean by thermal? It relates to temperature. So a thermodynamic process that takes place at constant temperature is called isothermal process. In isothermal process, pressure and volume may change. So the internal energy of the system remains constant in isothermal process. For example, fusion of ice or boiling of a liquid. The next process is isobaric process. What's the meaning of baric? It is pressure. Okay. So a thermodynamic process that takes place at constant pressure is called isobaric process. For example, conversion of ice into water and the conversion of water into steam. Next, isochoric process. The term choric stands for volume. So a thermodynamic process that takes place at constant volume is called isochoric process. In this process, the work done is zero. For example, atmospheric change, explosion in gases, etc. Next, adiabatic process, a thermodynamic process in which no heat leaves or enters the system is called adiabatic process. That is, heat remains constant in adiabatic process. For example, a reaction carried out in a thermos flask, heat engine, puncture of a tube, air bubble, refrigerator, etc. And this thermodynamic process we will study in detail in thermodynamic potentials. Okay. So next comes thermodynamic properties. So thermodynamic properties are defined as the characteristic features of a system capable of specifying the system's state. Okay, so it is defined as the characteristic features of a system capable of specifying the system's state. Thermodynamic properties may be of two types. They are intensive property and extensive property. So intensive property, this is the property whose value do not depend on the quantity of matter present in the system. For example, pressure and temperature. Next, extensive property, this is the property whose value depends on the quantity of matter present in the system. Example, volume, mass, energy and enthalpy. Enthalpy is nothing but the total heat of the system. Okay, enthalpy is a measure of total heat of the system. Next, thermodynamic equilibrium. A system which is in thermal, mechanical and chemical equilibrium is said to be in thermodynamic equilibrium. Okay, so three equilibrium should be maintained for a system to be in thermodynamic equilibrium. They are thermal equilibrium, mechanical equilibrium and chemical equilibrium. Now what is thermal equilibrium? A system is said to be in thermal equilibrium if the temperature of the system remains same as that of the surroundings. Okay, so a system is said to be in thermal equilibrium if the temperature of the system remains constant with the surrounding. Next, mechanical equilibrium. A system is said to be in mechanical equilibrium if there is no net force in the interior of the system or between the system and its surroundings. So a system is said to be in mechanical equilibrium if there is no net force in the interior of the system or between the system and its surroundings. Next, chemical equilibrium. A system is said to be in chemical equilibrium when its chemical composition is same throughout the system. Okay, when its chemical composition is same throughout the system. This is all about thermodynamic equilibrium. Next comes quasi-static process. So in thermodynamics, a quasi-static process, also known as quasi-equilibrium process, is a thermodynamic process that happens slowly enough for the system to remain in internal thermodynamic equilibrium. That is a process that happens very slowly so that it is not going to affect the system, and therefore the system continue to remain in internal thermodynamic equilibrium. Okay, in other words, the process in which the deviation from the thermodynamic equilibrium is infinitesimal. What do you mean by infinitesimal? It is very, very small. Okay, so the deviation from the thermodynamic equilibrium is infinitesimal so that the system continues to remain in internal thermodynamic equilibrium. So once again, what is quasi-static process? That is a thermodynamic process that happens very slowly so that the system continue to remain in internal thermodynamic equilibrium. Fine. Next comes PVT diagram, that is pressure, volume, temperature diagram. So we represent this diagram by means of a graph. So a graphical representation of the states of a pure substance which must have two independent properties and the third dependent is obtained by a three-dimensional plot called the thermodynamic surface or PVT surface. Okay, or the PVT diagram. So what is the PVT diagram? It is a graphical representation of the states of a pure substance which must have two independent coordinates and the third coordinate is dependent. Okay, and we can represent it by means of a three-dimensional plot called the thermodynamic surface or PVT surface or PVT diagram. So, as it is complicated to study a 3D plot, we can discuss a simple projection of a thermodynamic surface on a 2D plane. So, it is difficult to explain or to study 3D plot. So, to make it simpler, we are going to study in a 2D plane. Correspondingly, we have PV plots, VT plots and PT plots. Each of these diagrams is a line. For an ideal gas, the PV diagram is called indicator diagram. The PV diagram, when T is a constant, is represented by the equation PV is equal to constant. So here I am telling PV diagram. There is no T. So I consider T as a constant. Okay. So in such a diagram, PV is equal to constant. Next, the PT diagram is called phase diagram. The PT diagram, when V is a constant. So here there is no V term. So I assume V is a constant and is represented by the equation P by T is equal to constant. Whereas in the previous case, PV is equal to constant. Here P by T is equal to constant. Next, VT diagram, when P is a constant, is represented by the equation V by T equal to constant. Okay, here there is no P, so I make it constant and it is represented by the equation V by T is equal to constant. So the following diagram shows PV diagram for various processes exhibited by an ideal gas. This is the graphical representation. We have pressure towards y-axis and volume towards x-axis. So this is the PV diagram. In this diagram, AB represents isobaric process. Okay, this region AB represents isobaric process. AC represents isothermal process. AD represents adiabatic process. And AE represents isochoric process. Okay, so this is how PVT diagram is represented. Next is equation of state. All thermodynamic systems are characterized by thermodynamic coordinates, pressure, volume and temperature. So pressure is P, volume is V and temperature is T. Out of these three coordinates, only two are independent coordinates. This implies that there exists an equation of equilibrium which connects the thermodynamic coordinates. This is called equation of state. So what is an equation of state? All thermodynamic systems are characterized by thermodynamic coordinates. They are pressure, volume and temperature. Out of these three coordinates, only two are independent coordinates. This implies that there exists an equation of equilibrium which connects the thermodynamic coordinates, and this equation is called equation of state. An equation of state is the mathematical function relating the appropriate thermodynamic coordinates of a system in equilibrium. So we can define equation of state as the mathematical function relating the appropriate thermodynamic coordinates of a system in equilibrium. Every thermodynamic system has its own equation of state. At low pressure, the equation of state is represented by the ideal gas equation PV is equal to nRT. where N is the number of moles and capital R is the molar gas constant. P, V and T we know. P is pressure, V is volume and T is temperature. So this is for low pressure. Now at high pressure, the equation of state is represented by the van der Waals equation. Okay, that is the real gas equation. That is P plus A N square by V square. V minus NB is equal to nRT, where A and B are constants and N is the number of mole. These are all about the basic concepts and zeroth law of thermodynamics. Hope you all understood. Thank you.